Okay, today we're going to start with 5.2. I have no idea. What did I talk about last in here? I can't remember. I know I talked about the project. Did we go into 5.2 yet?
No, we were still in 5.1.
Okay.
I think we finished
so,
5.1 though.
Well, yeah, I think the only thing that I didn't talk about was subjective. And subjective, I'll show you right quick. And I usually don't talk about subjective too much, but we'll go ahead and talk about it. And that's subjective right there. Okay, and from current slide. When I talk about subjective, I usually talk about subjective and suppressive at the same time. And I only talk about it mainly so if you see it on a standardized test, you'll know what basically it means. And here we go. Subjective is anything that has, I guess you would say, feeling, emotion in it. Feeling / emotion. In other words, a subjective poll, a subjective question. I don't know why this thing's not. There we go. Maybe that's a little bit better. For some reason it's not. Let me turn it on automatic and maybe it'll. Focus. Where's focus on this thing? Okay, it's supposed to be on focus. There. I'll have to see what those other ones are, but that looks good right now. All right. Subjective, you could have a subjective poll. You could have a subjective question. You could have a subjective statement. Okay? All three are not good. Okay? I'm going to turn off my video here. Save a little bit of bandwidth. Why do you not want subjective polling or subjective questions? Because subjective is kind of anti-neutral or biased in a slight way. Okay? If I put out a question or a statement that has my feelings in it or my emotions in it, then that's when it becomes less neutral. I'm just going to say less neutral. I don't even know if I spelled neutral right. I hope I did. But anyway, less neutral. You don't want to put emotions or feelings into any one of these things. Okay? And the last thing that we want to talk about is suppressive. Suppressive polls, questions, and statements. What are suppressive? What does the word suppressive mean? Well, let's look it up. Dang old, that's what dang old Google's for. I don't know if I spelled it right. Suppressive definition. tending or acting to suppress. That don't tell you anything. Let's see if we can find a better. Well, you're not supposed to use a word to define a word, but I don't see any. Okay, suppress. Prevent development, prevent the dissemination or information. Okay, so you don't want when you're doing probability and statistics, suppress information. Shoot. Suppress information. And I know I didn't spell that right. There's some words that I just suck at. And anything that has a lot of double word letters in it. Did I get that right? Okay. I got it right. Okay. You don't want to hide information, or you don't want to suppress information because of your what? Your feelings or emotions. Okay, so that's the two. So if I tell you the sky is blue, that's not really subjective. But if I tell you, I think, usually when you see the word think, or you see the word feel, okay, or some words like that, you're going to be talking about a suppressive poll or statement or question. I mean, sorry, not suppressive, subjective. Okay. I think John is a better person for the job than Susie. Okay. That's subjective. I think this teacher is a better psychology teacher than the teacher we had last semester. That is subjective. Suppressive is when you give information to kind of suppress the information that needs to be given. Let me give you an example. Let's say I put out a poll to the class, and the poll says that I interviewed 50 people, and 50 people out of 50 people, 40 people says that, hold on, out of 50 people, 40 people says that smoking is bad for your health. For your health. Well, I don't want to stop people from smoking, so I'm going to present this in a way that says 10 out of 50 or 1 out of 5, smoking is good. Okay, so I really turned the data into something that looks better because I have injected my feelings into the poll or the statement or whatever. This looks better than this. Okay, and if you take out the zeros, it's 4 out of 5, at least 1 out of 5. So these two kind of work together, and both of them basically help in bias. Okay, they're not good for neutrality. Okay, that's all I'm going to say about those two things. Did Miss Dennis ever get in? That gummit. She must have her kids, or I think she told me their kids were doing virtual, so she might be teaching them or help teaching them. Okay, so next, 5.2. I'm going to just give you a rundown of 5.2 and then we'll do some questions, okay? I can't remember if 5.2 covers addition or multiplication, so we're going to do both. And then we'll do examples. All right, the additive rule. The additive rule of probability. There's an additive rule and a multiplicative rule. The additive rule, and I'm going to get my red pen out so you know that's important. The additive rule, if I could find it, because I've got so many magentas. Here's one here. The additive rule, you've got to remember two things about the additive rule. Number one, the word or. When you see the word or in the question, that means you're going to use the additive rule. What is the probability of a king or a queen in a deck of cards? Boom, there it is right there. And you're going to see that usually in the last sentence of the question. The questions will say, find the probability of a king or a queen. And then, of course, you would write it like that. Okay, usually it'll say, find the probability of a blank or a blank. And there is your indicator right there. The second thing you have to remember about the additive law is always subtract the overlap. Now, I know y'all are not going to believe this, but I'm going to teach you kind of unconventional on this problem, unlike other math teachers. Now, I know that sounds, that surprises you, but most of the time, the additive rule works better when you put your data in some form of a table. And those are the three red things that I'm going to put down, meaning those are very important. And you need to write these things down and memorize them in order not to suck at the additive law. Now, I'll get to the overlap when we go over the problem, okay? So the problem the example that I always use came from another book, the book that we used for so long that was so good. And of course, at Tri-County Tech, when something ain't broke, you fix it, okay? So we have a good book and we used it for so many years and had good information in it and we switched. So I'm going to use that example, and that's blood types. So blood types, and I'm going to go over here and I'm going to use my blood types. And I'm just going to make some numbers up. RH negative, RH positive, and of course you got O, A, B, and AB, I think. Okay. I can't remember exactly how this works. Hold on just a second. Okay, I'm sorry. I had to tell my son where the cereal was. All right. So let's go with, we know that, I can't remember, which one is the most rare? AB negative? Isn't that the most rare?
Something like that.
Okay, so we make that 2 and 3, and then we'll make these bigger. 7, 8, 5, 3, 4, 6. Okay, so there is our example. Now, I'm going to tell you to write this example down because does anybody know how many problems are in this example? Probably about 10. And you can make them up yourself. 10 problems right here in this. That's why I use this one as an example. So the first one we're going to do is I'm going to do the probability of blank or blank. And I'm going to use colors because y'all know that y'all learn better with colors, right? So I'm going to use pink and green. Pink, I'm going to put A. And green, I'm going to put B. So the question will say, blah, 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 different blood types, blah, 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 blah. What is the probability? And the blah, blah, blahs will tell you to make this chart. And then it'll say, what is the probability of a blood type being A or B? And then you, of course, write that. And then you take your handy-dandy highlighters, and pink would be the A column, and B would be the B column. And you would, first of all, you got to find a total because your total is the denominator. Okay, you need to write that down somewhere. Let's write that down in red. Total equals denominator. So you got to find your denominator. So I'm going to add these up. I'm looking for a 10, looking for 10s. Okay, there's a 10, there's a 10. So we got 20, and there's a 10, that's 30. So I think we got 38. Somebody check my math, please. 8 and 2, 6 and 4, 7 and 3. I believe we got 38.
That's what I got, yeah.
Good. Somebody's still adding the old way. 7 plus 8 plus 5. You add your 10s first. Always. Is there Miss Dennis in here? Okay, Miss Dennis, you got to quit showing up late. I tell you what. I don't know what I'm going to do with you. Okay, she's not going to talk to me this morning. She's mad at me. All right, so my denominator is going to be equal to.
Good morning.
5 minutes later.
I have to do school drop off.
What?
I have to do school drop off.
Okay, well, your priority is not your kids. Your priority is math class, okay? So you need to carry your laptop and your desktop and your phone, and you need to attend class while you're driving, okay?
I started to do it in the school parking lot, to tell you the truth.
What school parking lot are you in?
McCants.
Oh, are you actually in the parking lot?
No, I just left. I started to, I said, but I was like, no. Yeah.
Whereabouts you live in relation to McCants?
On 28.
Oh, okay. So you have to go through town.
I guess that's what you call it. I don't know.
Well, yeah. If you're in McCants, that's on 81, and you live on 28. Yeah.
Next to the school district building. I live right next door.
Oh, okay. Yeah, we just on land use board, that Wendy's right there, right beside the district office. Yeah.
I'm trying to get out of here because that's going to be crazy. My bedroom window is right here at Wendy's.
Oh, my Lord. I know where you live then. I'm going to come over there and throw beer bottles in your yard. Okay.
You can come over and throw math problems at me.
Okay. So I'm going to add 8 plus 4 in pink. And what is this called? It's called the additive law. So that means I'm going to add. And 5 plus 6. And I always subtract my overlap. Is there any overlap of the pink and the blue and the green? No. So I'm not going to subtract anything because there's no overlap. So 12 plus 11 minus 0. And the reason I'm minusing the 0 is I'm going through the motions of always subtract the overlap. In just a minute, you'll see why. And all that over 38. And 12 plus 11 is what? 23? So our answer is 23 over 38. And of course, that will be a decimal. So depending on your directions, that is your answer.
Where's this problem?
Say again?
Where is this problem?
I just made it up.
Oh.
This actual problem came from a book that we used several years ago. And the reason I like to use it is because, one, you have about 10 different problems in this problem. So you can make up problems. See, I can do O or A. I can do B or AB. I can do A or O. I can do B or O. I can do AB or O, whatever. I can do like 4 or 5 different problems just with the non-overlap. Okay.
And what part of chapter 5 does this have to do?
This is 5.2.
Okay.
Okay. All right. So that's one type of problem you're going to have with the additive law. No overlap. No overlap means 0. All right. So now let's do one with overlap. So what I'm going to do is I'm going to copy all this over. So I need you to copy it all over. Why? Because we don't have one. I'm going to use my highlighter again, and I don't want you to use highlighter on top of highlighter because then you'll get confused. So let's redraw the table. And I don't know if you caught this, Miss Dennis, but most of your problems with the additive law, usually it helps if you put it in a table. Okay. So if you got a paragraph as a question, more than likely they'll want you to put it in a table form because it works a whole lot better. RH negative, RH positive. And I'm going to redo same numbers. And this is O, A, B, AB. 2, 3, 5, 6, 8, 4, 7, 3. Now, the probability, blah, 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 blah. It's going to give you all this stuff to draw this thing. And then it's going to say, find the probability of blank or blank. And then you write, okay, they want you to find the probability of blank or blank. And in this case, we're going to find the probability of RH positive or AB. So I take my handy dandy pink highlighter and I draw that. And then I take my green highlighter and I draw that. Now, of course, our denominator is the same. I think we said it was 38. And now I just do what I'm supposed to do. 3 plus 4 plus 6 plus 3. Add, because it's called the additive law. 2 plus 3. And you always subtract your overlap. What's our overlap? 3. And now you just do the math.
How do you know 3 is your overlap? I'm sorry.
Because what right here, what do you see inside that circle?
A 3?
Yeah, but what about the colors?
It's circled in red.
The colors of the green and the pink, what do? They overlap.
Oh.
See the pink and the green?
Yeah. Oh, okay. Okay.
And don't be surprised, Miss Dennis, a lot of people ask that same question. So I guarantee you there was 2 or 3 people in here that are saying, well, how does these return number overlap? Where the colors overlap, that's what you put right here. Okay, so 3 plus, okay, I want a 10 here because 10s are easy to add. So 4 plus 6 is 10, plus 6, that's 16. So I got a 16 here, plus 5, minus 3. God, the things I do for y'all with all these colors, divided by 38. 16 plus 5 is 21. 21 minus 3 is 18. So your final answer is 18 over 38, which you can simplify as a fraction or turn it into a decimal. I'm not going to simplify. Y'all should be able to do that. It'd be 9 over 18 or no, 9 over 19 or something like that. Okay. Oops, I'm sorry. Hold on. There we go. Okay, now that's the 2 types of questions you're going to have with the additive law. You're not going to have any other type questions. You're either going to have one that doesn't overlap, or you're going to have one that what? Overlaps. So you need to make the distinction which one it is. Non-overlap. What is non-overlap called? Non-overlap, and they'll put this in the homework, and I'll put this in red. Non-overlap is called disjoint. Non-overlap. So if you have a set of data like this, and they say A or B, and your colors do not overlap, that means you have disjoint data. The only reason I say that, I don't usually ask that, but there may be a homework problem or possibly a test question that may ask that. It may say, is this disjoint?
Can I ask you, what did the problem say when it wasn't an overlap to make you know that P, did it say find the problematic?
The question will say, find the probability of blank or blank. Okay? Or is the word that tells you, let me go back here because you might have missed this. Okay? The additive law of probability. Usually you want to put it in a data table if you can.
Okay.
And the word or will show up in your last sentence. It'll say find the probability of blank or blank. And that tells you the additive law. And the additive law is basically the only thing you have to remember is or and always subtract the overlap. So in this problem, they just gave us the numbers. RH negative is 7, 8, 5, and 2. RH positive is 3, 4, 6, and 3. And then they'll say O is 7 and 3, and they'll give you this, okay? Now, sometimes they'll give it to you a simple table. They'll give it to you in a in a paragraph form, and it's real simple. And you can put it in this one is not simple in paragraph form. This would be like a half a page. They're not going to give you they'll just give you the table if it's long and drawn out. Okay? So here it'll say probability of A or B. So you take your highlighter and you highlight A. And you take your highlighter and you highlight B. There's no overlap of the colors of the two highlighter colors. So there's no overlap, so it's disjoint. Where this one is, what does the highlighter colors do? They intersect. Yes, they overlap.
Okay.
Here, you've got, I guess you would call this jointed, but they don't use that. They just use the disjoint.
Okay.
They don't really have a word for this because there's an overlap.
Okay. Thank you.
Now, the way they show you, yes, ma'am, the way they show you this in the notes is they use a Venn diagram. And where is the Venn diagram? There. Now, if something overlaps, okay, this is disjoint, because do the circles overlap?
No.
The circles do not overlap. So if there's no overlap, it's called disjoint. Sorry. It's called disjoints because they have no outcomes that are what? In common. In common is another word for overlap.
Okay.
See? Right here. Hold on. I got to go back and hold on. Let me do this. I was going to try to get it inside. Hold on. I don't know if I'll be able to do this or not. Well, I'll just do this. Okay. Two events are disjoint if they have no outcomes in common. No outcomes in common would be that one right there. An outcome in common, there's what's in common right there.
Okay.
So relate to yourself. Overlap, common. No overlap, nothing in common. Okay, so I want to see, they got to have one where they combine. Well, I guess not. See, I disagree with that because they should show you one that does and one that would be in common. Let's say that, I'll draw one for you. Let's say that this set, I remember these in first and second grade at Varenus. Set A has these numbers in it. 1, 2, 3, 4, 5. And set B has these numbers in it. 4, 5, 6, 7. So if I was to draw this in a graphical representation, what numbers would be in the overlap right here?
4 and 5.
4 and 5. Good job. So I'm going to write that in pink. 4 and 5 would be in common. And the rest of them would just be hanging out there. 1, 2, 3, and then 6 and 7. And then I'm going to just add right here. This is called, oops, I didn't mean to do that. I didn't think it would disappear on me like that. Well, I'll just go ahead and overlap, and then I'll just put a different color, 4 and 5 right there. 4 and 5.
Come on, Mr. Huber, get your artistic skills in order.
I know, I suck. Overlap is also called in common. All right, so that's the way they show you, with the Venn diagrams. This is called a Venn diagram. VENN diagram. Okay, that's called a Venn diagram. Or you could just say where the two colors overlap. Okay, so let's do a nerd. Okay, I'm gonna let y'all do this one. I'm not gonna give you any help. I'm gonna let y'all do it. RH negative, RH positive. O, A, B, and AB. 2, 3, 5, 6, 8, 4, 7, 3. And I'm going to do probability, blah, 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 blah. What is the probability? This is what the question will say. What is the probability of RH negative or O types? That's what the question will say. What is the probability of RH negative or, that tells you the additive law, O types? So I want you to draw a probability of blank or blank, and I want you to put, if you've got the ability, if you've got crayons, colored pencils, or highlighters, I want you to use two different colors, and I want you to put the first one in one color, highlight it, the second one in another color, highlight it, and then find out if it overlaps or not. So give you a minute. It's 8:44 right now. I'm going to give everybody a minute. Go ahead and do it. And if you can't do it, we'll just mark it up as failure. Failure for the day. So, Miss Dennis, what part of the North are you from?
Massachusetts, Boston.
Oh my gosh, I love to hear people talk that are from Massachusetts. I do, because people think that country people live in the South, but if you think about it, some of the people that live in Boston, they pronounce W-A-S-H as wash.
Worse.
Yeah. It's worse. Yeah, you're right. Now, people in Kentucky do that too. They'll say wash. My mama, she's from Belton, and she says watermelon. So I guess we all have our little intricacies in pronouncing things. Yeah, my mama was born and raised in Belton, and she says watermelon. All right. So, yeah, Boston, I love to hear people. I went to a conference up there one time, and I love to hear people talk like that. Talk Boston. So this is a Harvard bar. I love it. All right, so I'm going to call RH negative. I'm going to call that pink, and I'm going to go straight across. And then I'm going to pick another color because my green highlighter is skinny, and I'm not going to use it. I'm going to use my big highlighters because it's easier. And O, I'm going to make it yellow. And now I'm going to write in pink and yellow. Now this yellow shows up, believe it or not. I can't believe how well it shows up on this, not the highlighter, I'm talking about the one I write with. Usually the yellow pens I write with, you can't see it hardly, but for some reason, these two yellow ones that I've got, they must be dark yellow because they show up real good. So there's the O, and there's the RH negative. Because usually the other yellows that I have, you wouldn't be able to see that 0 right there, or that O. You wouldn't be able to see it. All right, so here we go. I'm going to take my handy dandy brown because I'm just going to make brown. I usually use black. Oh, shut up. I'm going to have to. Oh, they have to leave a message. 38. Okay. There's my, I think we had a total of 38. And I'm going to take my pink and I'm going to hit 7 plus 8 plus 5 plus 2. Take my yellow.
Where you get 38 from?
That's the total. Remember, I put that up in the top left-hand corner. Remember, your total, you got to get the total first. Total equals denominator.
The total of everything?
Everything, yes.
7, 3, 8, 4, 5, 6, 2, 3.
See here? See our first one? Let's see our first one.
Oh, I'm right.
Total equals denominator. And 38. 38. And 38. You always got to get your total first because that's going to be your denominator. With the additive law and the multiplicative law, which we go over next, you've got to have a denominator, and the denominator is usually your total. And then I'm going to add, because it's the additive law. Oops, wrong color. I'm going to add 7 plus 3. And then what is my overlap?
7 and 3.
Good job. 7. Where do the colors overlap?
Oh, okay.
7.
7.
Minus 7. You always subtract the overlap. And that right here, and then I'm showing you this because you came in a little bit late. Always subtract. Even though this is the additive law, when it comes to the overlap, you always subtract the overlap. All right, now it's just nothing but basic math. So let's see, 8 plus 2 is 10. Plus 17, 7 and 3 is 10, so that's 20. And then 2, I got 22. What do y'all get?
22.
22 plus 10 minus 7. All over 38. Well, 22 plus 10, or you could do it the easy way. 10 minus 7 is 3. 22 plus 3 is 25. So you should get 25. 22 plus 10 is 32 minus, yeah, you should get, did I say 25? I think I said 25.
That's what you said.
And that's equal to a decimal. So whatever decimal that comes out to be, that is your answer. Now, again, I'm not worried about reducing. Y'all should be able to reduce I just write down the fraction and turn it into a decimal and read your directions on where to round it. And that's how you do the additive law. Now, what about the multiplicative law? Well, the multiplicative law, remember when I gave you the additive law, and I told you that there was a couple of things that was very important to write down about the additive law. Same thing with the multiplicative law. The multiplicative law of probability. Of probability. The multiplicative law of probability, you're looking for the word, not or, but. Anybody remember? You had this before? You had it in high school. Does anybody know?
Is it and?
And. Good job. You're looking for the word and. What is the probability of blank and blank? What is the probability of a king and a queen being chosen? And the question will say, find the probability, and this is usually your last sentence in the question. Find the probability of blank and blank. And there is your key word right there. I don't know why I put a 2 there. That should be a 1. And 2, before in the additive law, you had to worry about the overlap. In the multiplicative law, you have to worry about replacement. Now, I'll explain that in just a minute. But there's 2 outcomes with replacement. With replacement and without replacement. With replacement, the statistics do not change. Math doesn't change. Without replacement, the math changes. With replacement is also called independent. Without replacement is called dependent. Now, most of the time, this will be given in the question. But after so many digits above 300, I usually tell students, if you have samples that are above 300, it doesn't matter which method you use. Okay? Above 300, it doesn't matter. And I'm going to show you that in just a minute. So with the multiplicative law, these are your important things to watch out for. First of all, look for the word and. Usually in your last sentence of the paragraph or the question, it'll say, find the probability of blank and blank. Whereas the additive law, it was or blank. Look for anything having to do with replacement. It'll either say with replacement or it'll say without replacement. It could say independent or dependent. Independent means with replacement. Dependent means without replacement. Now I'm going to go into, I'm not going into the multiplicative law. I'm going to show you what I mean by replacement and without replacement. I'll leave that up for another couple of seconds. Let me get another marker.
What did the above 300 have to do with anything again?
Above 300, you don't have to worry about which method to use, with replacement or without.
Okay.
You'll understand that better after I go over that problem. Okay. So this, I have to write it out because some people think I say Marlboros like in the cigarette. No, a marble bag. Here is a marble bag. Now, another test and homework question. Golf ball bag. Okay. A lot of the homework questions or test questions, instead of a marble, they use golf balls, different color golf balls. So you can apply this, what I'm fixing to show you, you can apply it to some of your homework questions or test questions that instead of marbles, they say golf balls. All right, so in this bag, we've got 4 red marbles. We've got, I have to use a different, let's see, that green right here will show up. 3 green marbles. Blue, of course. I better use this blue because this blue may not show up. It may show up to be like black. 5 blue marbles. And my favorite color, yellow. 4 yellow marbles. Okay, so homework, I know a couple of your test questions are golf balls. And it'll say there's a golf ball bag that has 4 red golf balls, 3 green golf balls, 5 blue golf balls, and 4 yellow golf balls. So I just wanted to show. I want you to find, this is what the question will say, find the probability of pulling out a red and a blue, blue marble with replacement. Okay, it'll say something like that. It'll say with replacement or without replacement. It may say independent or dependent. It may say being dependent or something like that. Find the probability of pulling out a red and blue marble. So that would mean I'm going to take this. I got to get a total. I got to get a denominator first. So I'm going to take my handy dandy up here. I'm going to take my red marker. Well, not red. I can't use red. I've already used red. Let me use orange. Okay. 1. Get denominator. Okay. You got to get the denominator. So denominator in this problem is going to be, let's see if I can find
16.
a 10. I can't find a 10. So I'm finding 9.
16.
And then 1 from that, that would be 12. I got 16. What do y'all get?
16.
Is 15. 9, 10, 11, 12. I got, y'all check me. I got 16. What do y'all get?
16.
Oh, I thought you said
16.
16. Okay, I thought somebody said 15. I'm sorry. All right, so my denominator is 16. So I'm going to put 16 right here and 16 right here and a multiplication symbol right here. And I'm going to put a 5. Let's see. Red is 4. And a blue is 5. And I just take my handy dandy calculator and multiply 4 times 5 and 16 times 16. That's it. Okay. So that would be 9 over, well, 16 and 16. I know that, I think that's going to be 256. Let's see, what's 15 and 15? That's 225. Somebody check me, what's 16 times 16?
256.
It's a miracle. And change that into a decimal. Okay,
Wait,
now I'm going to show you one that
I
will
have
say
9.
without replacement. Okay, so see if anybody's got any questions on that one.
Why you have 9 over 256?
Because I'm on drugs. 20 over 56. Thank you, Miss Dennis. 20 over 56. Thank you. And change that into a decimal or reduce depending on what the directions say. 4 times 5 is 20. 16 times 16 is 256. Now, this is when they ask you a red and a blue. Now, let me give you another example because multiplicative law, instead of having 2 examples, which the additive law has 2 examples, in other words, without overlap and with overlap. There's several questions that they can ask you about the multiplicative law. The first question is one that says a red and a blue, different colors. So we're going to call this one different colors. So that would be this type question. And they say a red and a blue. So let's see the ones that they ask with the same color. And there's 2 different ones that they're going to ask with the same color. One with different colors. This is the one they're going to ask. With the same colors, this is what they'll say. Draw my marble bag. And we got 4 red, 3 green, 5 blue, and 4 yellow. Now the question is going to say, what is the probability of picking 3 reds in a row without replacement? What is the probability of picking 3 red marbles in a row? You're only allowed to pick 3 marbles. What they're asking you is, what is the probability of all 3 picks being red? Now, most of y'all will say, with common sense, that's a very low probability because you got other colors in there. So yes, it's going to be a very low probability. Okay, what is the probability of picking 3 red marbles with replacement? Now, when you're talking about the same color, this plays in effect very much. Okay, the different colors, it really didn't matter because you only had 2 picks. Okay, and they were different colors. When it's the same color and you've got more than 2 picks, excuse me, and you've got more than 2 picks, more than 2 picks. Here we got 3. Okay, when you got more than 2 picks, this with and without replacement makes a difference. So technically, they're asking us to pick a red. What is the probability of picking a red and a red and a red? That's what they're asking us to do. What is the probability of picking a red and a red and a red? So the and means multiplicative law. Now, what does the with replacement mean? Well, if I tell Miss Dennis to put her hand in the bag and pick out a marble, she picks it out, writes the color down. What does she do with the marble after she writes the color down?
Puts it back in the bag.
She puts it back in the bag. That's with replacement. Some people, depending on the experiment or the situation, would pick the marble and put it on a table and write the color down and leave it on the table. What is that called? Okay, if I put the marble back in the bag, that's called without replacement. If I leave it on the table, it's without replacement, and now the number of marbles in the bag has changed. So the math has changed. Okay, now this is with replacement. So when Miss Dennis picks a marble out of the bag, she records it, she writes it down, and then she puts the marble back in the bag. So the math doesn't change. There's still 4 reds, 3 greens, 5 blues, 4 yellows, and, hold on, 16 total still in the bag. Everybody with me?
Yes.
So with replacement, you've got to actually think, I want everybody to think of each one of you reaching in the bag, pulling out a marble, writing it down, the color, and putting it back in the bag. That's called with replacement. It's also called independent because, I'm sorry, dependent or independent. Yeah, I've got it backwards. I think I got it backwards. Because, just remember, the math doesn't change. I think I meant independent. I get those two mixed up all the time. So on your original multiplicative law, switch those. Yeah, I did. With replacement is independent. Okay. Sometimes I get them mixed up. All right. So somebody tell me what the probability of a red marble would be.
4 out of 16.
Okay, so that would be 4 out of 16 times 4 out of 16 times 4 out of 16. I just multiplied because I got the word and here. And wait a minute, I can rewrite this as 4 over 16 raised to the what?
Third
power. And let's highlight that third. I'm going to highlight it in orange. That third represents, the exponent represents the number of times I pick. So you could just do a shortcut and say Well, whatever it says 5 marbles, then that would be to the 5th power. So that is the number of draws, okay? Each time I'm going to draw a marble out. So if this said 5 red marbles, of course 4 red marbles, then this exponent would be 4. If it said 5 blue marbles, then this exponent would be 5. If it said 2 yellow marbles, then this exponent would be 2. Okay? Whatever the pick is, that's that exponent. Now, of course, you could change this to 1/4. I'm not worried about that because that's mathematics, and 4/16 is same decimal value as 1/4. So whatever you want to do, it doesn't matter to me. Okay, so I'm going to change that just for those of you that want to change it. That can be 1/4 raised to the 3rd power. Each one will give you 0.25 raised to the 3rd power. And somebody take 0.25 and raise it to the 3rd power for me. And give me 4 decimal places, please. 0.25 raised to the 3rd power.
0.0156.
Now, take it to 4 digits. When you're doing the multiplicative law, take it to 4 digits because they're going to ask you to take it to 3 on the test or the homework. Okay? That's how you do the multiplicative law. Now, remember, there's a difference in this one. This is a cat right here, and that's a tiger. Okay? Both of them have 4 legs, a tail, and whiskers. But this one is 2 marbles, and this one is more than 2.
This one here, where you have 1/4 at the bottom, that's what the breakdown of 4/16?
Yes.
Okay.
Either way, you're still going to get the same answer. You're going to get 0.25 to the 3rd power. I just said for those that were wondering, because I know there's somebody out there that was going, well, can I reduce that 4/16 to 1/4? Yes, you're going to get the same answer. It doesn't matter. Okay, now the 3rd problem. The 3rd problem that you're going to have with this type problem. I'm going to do my origami here, save a little bit of time. And I'm just going to fold this Marlboro bag. There we go. Now the question is going to say, what is the probability of picking 3 red marbles without replacement? Or it'll say dependent. Now somebody tell me what the first draw would be. 4 over what? 16. Now what do you do with that marble after you pull it out and write down the color? What do you do with it? Put it on the table, right? And
yeah.
How many marbles are in the bag now?
15.
And how many reds are in the bag now? Instead of 4,
3.
3. And then I pick another one. I put that one on the table. How many are left in the bag?
14.
And how many reds are left?
2.
1, 2, 3. This is your first pick. This is your second pick. And this is your 3rd pick. So if this said 5 or 4, it would be 4, 3, 2, 1 over 13. If it said 5 blue, then it would be 5 over 16, 4 over 14 or 15, 3 over 14, 2 over 13, and 1 over 12. So ever how many picks you got, that's how many sets of parentheses you're going to have. All right, so I need somebody to do the math here. We're going to do on the top 4 times 3 times 2 over 16 times 15 times 14. I ain't Rain Man, so somebody's going to have to do the bottom for me.
3360.
3360. And what is 4 times 3 is 12, 24?
Yeah.
And somebody give me 4 digits on this one.
.0071.
Let me ask you all a question. Is there a difference between the two numbers? Yes. Y'all see the difference between the first one we did with replacement and without replacement? Do you see that? Is the numbers different? Yes. This is equal to a penny, and this one's close to a penny, but it's not equal to a penny. So you see a difference between the answers. So let's write something down about that.
How are you getting that decimal?
Take 24 and divide by 3360 in your calculator.
Oh.
You got a calculator with you, Miss Dennis?
Yes, sir.
Let's type it in.
Okay, I got it.
Got it?
Yep.
All right. Now, do you see a difference between the two answers, everybody?
Yes.
Okay.
Yes.
If the numbers are low, you will see a difference between the answers of with replacement or without replacement. You will see a difference in the numbers. Now let's change the marbles. Let's change the marbles. Watch this. Instead of, we're going to make a bigger bag. Instead of 4 red, we got 400 red marbles. Instead of 3 green, we got 300 green. Instead of 5 blue, we got 500 blue. And instead of 4 yellow, we have 400 yellow. And instead of 16 total, we have 1600 total. Are all of these over 300 or equal to 300?
Yes.
They're above or equal. Let's write that down. Now, this is a little rule that I've come up with, okay, over the last 20-something years, and I try to pass it along to students. There is no proof that's done in mathematics that proves that what I say is true. But as an introductory statistics course, which this is, you can go with this rule. If your quantities are 300 and above, meaning what's in the bag, it doesn't matter whether you use with replacement or without replacement. And I'm fixing to show you. If your numbers in your bag or your box or whatever is over 300, 300 and above, then chances are it's not going to matter. Let's see what happens. What is the probability of picking 3 red marbles? 3 red. Well, y'all said that was going to be 400. This is with replacement. With replacement. Well, that's going to be 400 over 1600 raised to the third power, which is 4 over 16 raised to the third power, which is 1 over 4 raised to the third power. And somebody give me 4 digits again. I think it's, is it 0.0156?
Yes.
Okay, all right, now we're going to do it without replacement. So that's going to be, this is without replacement. 3 picks, so that's going to be 400 over 1600 multiplied by, if I pick 1 out of 400, what's left?
399.
399, and how many is in the bag? 1599. If I pick another one, that's going to be 398 divided by 1598. Now I'm going to take out the handy dandy calculator because I want y'all to see me do this, not because all of y'all know how to use a calculator. That's not what I'm not showing you how to use a calculator. I'm wanting you to see that how to type this in and what the answer comes out to be. So here we go. Here's the handy dandy calculator that will not clear. There we go. Parentheses, 400. Yes, you could reduce that one, but you can't reduce the other ones. So it really doesn't matter what you type in. 1600 multiplied by, parentheses, 399 divided by 1599, close parentheses, times, parentheses, 398 divided by 1598. Close parentheses. I want to get 4 digits. My 4 digits are 0.0155. 0.0155. If I tell you to round to 3 digits, what's your answer is going to be?
Extremely close.
Well, actually, if I tell you to round to 3 digits, what does this one turn out to be? 0.01 what? 6. If I tell you to round this one to 3 digits, what will you get?
0.016.
So somebody tell me what happens when I have 300 and above in my quantities. What happens? It doesn't matter which method you use. So 300 and above, it doesn't matter which method. Now, why do I show you that? Because which method is easier to use? The exponent or this one?
The exponent.
The exponent is the one that's easiest to use in your calculator. So if you're given a quantity of 300 or more, all these are 300 or more, then chances are you can just use the exponential rule of multiplicative instead of doing this. And you should feel good about yourself. Now, I've just covered, I think I've covered 2 sections, but the reason I'm not sure is because this is a new book that we're using. It's only like the second, third semester we've been using it. And I have not gone over odds yet, and I should have gone over odds. So basically, I'm gonna have to go look right quick. I'm not worried about the roll because we've got perfect attendance in here. Tuesday, everybody was here, so I'm not worried about that. I've already taken the roll this week. Let me go to, I want to do something right quick. Where is my, there it is. I want to look and see where they bring in odds, because I should have gone over odds. E-text. We're using a book. It ain't like we're going to the porn sites. Gosh. Well, I'm waiting for the book to come up. Hopefully it'll come up. I know some of y'all are convulsing. I know. Just hold on. I'm trying to show you something here. If I can ever get to chapter 5. This book, I'm not used to this book, so I'm going to have to pull up and look at the descriptions on chapter 5. Okay. Somewhere, I'm going to go over odds with y'all Tuesday because I've gone over 5.2 and 5.3. I don't know why we haven't gone over odds. Let me show you what, write this down. I'm going to go over, I've went over 5.1, I've covered 5.2, and I've covered 5.3. Everybody with me? The only one left is 5.6, or I'm sorry, 5.5. Do not do anything else. Your homework for this test will consist of 4.1, 4.2, 5.1, 5.2, 5.3, and 5.5. Do not do anything else. Does everybody understand that?
Yes.
I'll write it down one more time so everybody will understand it for the recording. 4.1, 4.2, 5.1, 5.2, 5.3, and 5.5. That is what we're going to be tested on. Anything else, I'm going to delete it, so don't do it. I think 5.4 is also in there, but I'm going to delete that. So right now, y'all should be working on 4.1, 4.2, 5.1, 5.2, 5.3. That's what y'all should be working on. And that means I'm going to cover odds. I don't know where they've put odds, so I'm going to just cover odds Tuesday. And then after I cover odds, we'll go into 5.5. So we should be finishing up Unit 2 next week. So that means we'll be going over a test probably that next week, that Tuesday of the next week. So we'll go over 5.5 and odds this Tuesday coming up, or Thursday. And then the next week probably will be the next pretest or the next test review. Anybody got any questions? Okay, sorry I held y'all over. Get out of here. Y'all have a good day, and I'll see y'all Tuesday. Have a good weekend.
You too.
Miss Dennis, you be careful driving your car. Actually, you must have been down here a long time because you don't have much of an accent.
This is only my second year.
Well, you don't have much of an accent, though.
Maybe because I don't know.
You don't talk a lot. Is that it?
That can't be it.
All right. Y'all have a good weekend. I'm going to leave.
Bye.
Got to get ready for my next class.